Welcome all to this presentation. This video we have studied about the metal carbonyls. Why does carbonyl bind a metal through its less electronegative carbon atom than its more electronegative oxygen atom? What makes it a good pi acceptor? The highest occupied molecular orbital, called as HOMO, of carbonyl is weakly antibonding compared with oxygen atomic orbital and is an molecular orbital which is carbon based. Secondly, the pi star antibonding orbital, which is made lowest unoccupied molecular orbital called as LUMO, is also comparatively lower energy, which makes it possible to interact with metal T2G orbital of pi bonding. There exists a strong back bonding of metal electrons to the pi star antibonding orbital of carbon monoxide. See the image. The carbon monoxide have completely filled in bonding orbital. The sigma electron, 2p sigma electron completely filled to donate the electron to the metal to formation of metal carbonyl sigma bond formation. Again, at the same time, the filled metal and donate the electron to the empty antibonding orbital of carbon monoxide to formation of bi bond, such as bi back bonding. Now we are see the molecular orbital diagram of metal carbonyl. The carbon monoxide formation of in molecular orbital diagram, carbon present in the left side, oxygen present in the right side. The carbon electronic configuration 1s2, 2s2 and 2p2. The oxygen electronic configuration 1s2, 2s2, 2p4. The 1s2 electron sigma orbital and sigma star antibonding orbital and 2s sigma bonding orbital, sigma star antibonding orbital completely filled, and then remaining higher energy of 2p orbital have 2 electron in carbon, 2p orbital have 4 electron in the oxygen atom. The totally 6 electron filled in 2p orbital. The remaining antibonding orbital is empty orbital, such as pi star p of x, pi star py. The both the antibonding pi star orbital empty orbital. So therefore, the electron density of metal or electron donated by the metal formation of pi pack donation, formation of bi bonding. Clearly explain this picture. The metal donates the electron to the carbonyl, formation of pi pack bonding. At the same time, the carbon donates the electron to the metal, formation of sigma bond. Generally, the carbonyl groups are act as sigma donor and pi acceptor. The metal carbonyls divided into two types: homolytic metal carbonyls and heterolytic metal carbonyls. These metal carbonyls based on the ligand. In homolytic metal carbonyls, only one type of ligand is present. These metal carbonyls have only carbon monoxide ligands. The general formula MxCO means carbonyl and Y. Example, tetracarbonyl nickel complex. Next one, ketrolytic metal carbonyls. In ketrolytic metal carbonyls, more than one type of ligands present along with the carbon monoxide ligands. Other types of ligands also attached to the metal. These have general formula MxLmCOY. Example, dichloro dicarbonyl platinum. Metal carbonyls can be classified in the following based on the number of metal centers. These are mononuclear metal carbonyl, and polynuclear metal carbonyl. The polynuclear metal carbonyls such as binuclear and trinuclear, tetranuclear and pentanuclear or hexanuclear metal carbonyls. In some cases, these metal carbonyls have only one metal center. The general formula of the mononuclear metal carbonyls such as MnCO(n) times. For example, tetracarbonyl nickel complex. Polynuclear metal carbonyls. These metal carbonyls have two or more metal centers. This general molecular formula of the mononuclear metal carbonyls MxNyCO(n) times, such as carbonyl N times. For example, Mn2CO10. Another example, MnCO says manganese and cobalt metal bond. Remaining, the 9 carbonyl groups are attached to the manganese carbonyl. Based on the bridged ligands and polynuclear metal carbonyls can be classified into mu2 as a bridging formation. In this type of metal carbonyl, the carbonyl ligands connected two metal centers. For example, Fe2CO9. And the second case, mu3 bridging. In this type of metal, the carbonyl ligands is connected three metal centers. The mu3 means the number of metals connected with the carbonyl group. For example, cyclopentatene Fe4 and CO4. Next one, non-bridging carbonyl or terminal carbonyl. The terminal carbonyl means the only one metal atom binded with one carbonyl. In this type of metal carbonyls, there are no bridged carbonyl ligands, only terminal carbonyl ligands are present. For example, Mn2CO10. The each manganese have 5 carbonyl group. Next one manganese metal bond is present. Already we also saw this MO diagram of carbon monoxide. Next one, preparation of metal carbonyls. The first method, a simple method, directly using the carbon monoxide react with transition metals. Mononuclear metal carbonyls such as FeCO2 and nickel tetracarbonyl and binuclear metal carbonyls such as octahedral and dicobalt such as CO2, CO8 may be prepared by the direct reaction of carbon monoxide with finely divided metal at suitable temperatures and pressure. See the reaction. Nickel sulfide and 4 mole of carbon monoxide present in the gaseous state, 30 degrees Celsius and 1 atmosphere pressure, formation of tetracarbonyl nickel complex. At the same time, the 5 number of carbon monoxide react with iron, the iron present in the 2 plus oxidation state, 200 degrees Celsius and 200 atmosphere to formation of pentacarbonyl iron complex. The another reaction, the 2 mole of cobalt metal react with 8 mole of carbon monoxide at 150 degrees Celsius and 35 atmosphere pressure, formation of binuclear complex of octacarbonyl bicobalt complex formation. This main requirement of this method is that metal centers must be reduced low oxidation state to facilitate the carbon monoxide binding to the metal center through metal ligand pi-back donation. Already we know the metals are donate the electron to the carbonyl only through the metal to ligand back by bonding. Formation of sigma bond. The overlapping of empty hybrid star orbital on the metal with filled hybridized orbital HOMO on the carbon atom of carbon monoxide molecule results in the formation of metal carbon monoxide sigma bond. The central metal atom in the carbonyls transition elements. Hence, there is a vacant t orbital available on the metal atom except the lone pair of electrons from HOMO of the carbon monoxide molecule. As we know, the 5 d orbitals dfx, dfy and dfz, zx and dx square minus y square dz square. The available metal on the atom can be participated. The carbon monoxide donates the electron to the metal formation of sigma bond. The orbital with proper alignment is involved in the metal carbonyl sigma bond. See the structure. The carbon monoxide containing sigma orbital, there is a 2p of sigma orbital, donates the electron to the metal orbital of dx square minus y square, formation of metal carbon sigma bond. The next one, formation of bi-bi bond by back donation. In generally, the bi-back donation, electron donate the electron transfer from metal to antibonding orbital of carbon monoxide. This bond is formed because overlapping of d-pi orbital of or hybridized p orbital of the metal atom low-lying empty orbital such as LUMO unoccupied molecular orbitals on the carbonyl. The metal bibonding such as P of x and P of y is the lowest unoccupied molecular orbital of LUMO that can accept the electron's density from an approximately oriented field the metal, resulting in the formation of metal carbonyl bibond. Carbon monoxide is one of the most important pi acceptor silicon because of it has pi acidity. Carbon monoxide can be stabilized zero oxidation state of metals carbonyl complex. See the image. There is a bi-back bonding example of the metal donates the electron to the carbonyl. The metal containing DXZ donates the electron to the carbonyl, formation of metal carbonyl bi-back bonding. Example of metal carbonyls in the coordination compound. This is the first example, nickel tetracarbonyl. The nickel is a central metal atom. The central metal atom have sp3 hybridized orbital. 10 electrons are present. The nickel electronic configuration S2D8, 4:3D8. Therefore, totally 10 electrons present in the outermost orbital of nickel. The 10 electron will be paired. The remaining 4 carbon monoxide containing 1 4s2 orbital and 3 4p orbital. Totally, the 4 carbon monoxide donates the electron to the metal, formation of tetracarbonyl nickel complex. The hybridization sp3 hybridization. The sp3 hybridization means the geometry is a tetrahedral geometry. The nickel present in the central metal atom. The 4 carbonyl groups are attached in the regular tetrahedron. The exactly bond angle 109 degree. Thus the valence configuration nickel atom, nickel tetracarbonyl molecules, the electronic configuration become 3d10 and 4s0. Therefore, the s electron move towards the d orbital to formation of complete filled configuration. The nickel tetracarbonyl is a stable complex. The absence of unpaired electron, so that complex considered as a diamagnetic behavior. The carbon and nickel bond result formation of overlap between sp3 hybridized orbital. See the structure explanation. The nickel tetracarbonyl have tetrahedral geometry. The bond length between carbon and nickel 1.51 Armstrong. Thank you.